All right, so we're going to talk about the ambiguous case with the law of signs. Let's get started, folks. So, last time we talked about using law of signs for angle-side-angle triangles and angle-angle-side triangles. Two angles and a side. And law of signs works very nicely for these kinds of triangles. We said that possibly with side-side angle triangles, we have a possible ambiguous case. Yes?
What does ambiguous case mean?
That's what we're going to talk about today. Ambiguous means it's possible that we have more than one triangle that we can find. All right, so I want to talk about our possibilities for our side-side angles. So we have several different things that can happen. All right, the first one, and I'm going to say for all of these possibilities, the height is the key. So we're going to be comparing the heights of the triangle to the side of the triangle to decide what's happening. All right, so our first possibility, and I always draw, when we have a side-side angle triangle, I always draw it like this, because we don't know what's going to happen here. And I'm going to call that A, and that B. Angle B would be down here. So what we have for a side-side angle triangle, this angle is set. You can't change this angle. These two sides are set. You can't change those. So there's nothing that's moving here. All right, so our first possibility. And I'm going to draw in the height here, like so. There's my height. And we know from what we talked about last time that our height is B sine A, because the sine of A is H over B. All right, so our first possibility, A is less than B, and A is less than the height. Well, this side then is too small to connect down here. This is not going to change, so side A is too short. It can't connect. So in this case, we get no triangle. We can't make a triangle out of those two sides in that angle. The second possibility is we have something like this. And this is angle A, this is side B, and this is side A. And in this case, side A is, let me undo that, I want it just to be perfectly vertical. There we go. And that's my height, H. In this case, A equals the height. Well, if that happens, we get one right triangle. We can't make, the A just barely connects. It's barely long enough to connect there. It's exactly the height. And then we also have the possibility that we have our triangle situated like so. There's my angle A, and I'll draw in my height. And here again, H equals B sine A. In this case, A is greater than B, and A is greater than the height. When that happens, there's only one triangle. All right, so those are the nice kind of the nice easy cases where we have one triangle or no triangle. We can get a right triangle if this side equals the height. If this side is bigger than the height and bigger than B, then we get one triangle. The ambiguous case happens, what we mean by ambiguous case is there's more than one triangle that we can get. So let's look at that possibility. So here's what we have in that situation. There's angle A, there's side B, and there's angle B. And let me draw in the height here. And our height is still B sine A. Yes?
Is this still a SSA?
Yes. So we have side angle with all of these. H is still B sine A. In this case, A is less than B, but A is greater than the height. So A is smaller, this side is smaller than this side, but it's bigger than the height. What can happen here, the reason we call it the ambiguous case, is I could swing that side around on this pivot point, and I can connect a side here that is also length A. In this case, we get two triangles. One of them looks like our original triangle, like this. And one of them is this new triangle that I got when I swung that side over that looks like this. Both of these triangles have angle A, side A, and side B. They have the exact same side, and angle, but they're different triangles. Well, let's look at how those two triangles are related. Here is our original angle B in this triangle. And I'm looking at, I'm going to highlight this triangle here that I get when I swing that side around. These two sides of this triangle are the same. This is an isosceles triangle. So how are these two angles related? They're the same. Those two angles are congruent. How are these two angles related? They are supplementary. This green angle here is this green angle in this triangle. The two possible angle B's are supplementary. So what we have to do when we have the ambiguous case, when A is less than B, but A is bigger than the height, is we would use the law of sines on this triangle, that just like we've always done. and find, we can then, once we know this angle B, we can find angle C and we can find side C using the law of sines. Then we have to do the same thing with this other possible triangle by using this angle B that we find, using the law of sines, subtracting it from 180 to find this angle B. And then we can find angle C and side C. So we have to find both possibilities for that triangle. And the ambiguous case comes when A is less than B, but A is bigger than the height. Yes?
So when we get our answers, is it like we give them two definite answers?
Yes.
Is it possible to give more than two? Or
No.
Okay.
Just 2. You get 1, 2, or 0.
Okay.
And if A is obtuse, then we do not get an ambiguous case, because we either have this is angle A, that's side A, that's side B. If A is less than B and angle A is obtuse, we can't make a triangle. And the other possibility is we have this. There's angle A, there's side A, and there's side B. If A is greater than B, we get one triangle. Because I can't swing this side around and connect down here anywhere else until I swing all the way back around and get to there. So we just get one triangle. So our ambiguous case comes when A is acute, side A is less than side B, but side A is bigger than the height. In that case, our two possible angle B's are supplementary. All right, so let's talk about how we proceed with side-side angle triangles. One, always draw a picture. And in this case, I always draw my pictures to look like this, in that orientation. And I always purposefully leave this side exaggerated, very short, exaggerated side, because I don't know, is it going to connect? Is it going to connect in one place? Is it going to connect in two places? So I always draw my picture like that. Two, we need to calculate the height. So we calculate the height based on the information we have. From that information, we decide which case we have. Do we have one triangle? Do we have no triangle? Do we have two triangles? And then, depending on which case we calculate appropriately. All right, so let's look at some examples with side-side angle triangles. Questions so far? I think the ability to tolerate ambiguity is one of the best skills any math student can have, in general. I'm not joking. All right, so let's say that A is 26 degrees, B is 5, and side A is 21. We want to find, or we want to solve the triangle. All right, so I'm going to draw a picture. I always draw my picture like this. I don't know if this is going to connect. That's A, that's 26 degrees. This is 21, and this is 5. All right, A is greater than B. And let's calculate our height. There's my height. And in this case, H is 5 sine 26. And I'm not even going to calculate this, because is 5 sine 26 more or less than 5? Less, because the sine is only between 0 and 1. So this has to be less than 5. So A is greater than the height. So that tells us that we get one possible triangle. And then we would say, we would use law of sines. So I'm going to say one triangle. So I would say sine B over 5 equals sine 26 over 21. And I put the angle on top, the sine B on top, because I'm trying to find the angle. And from this, I get that B is the inverse sine of 5 sine 26 over 21. Solve for sine B and then take the inverse side, et cetera, et cetera. So we would, I'm going to say et cetera. This is exactly like the problems we worked on Friday. I would find angle B, find angle C, and then use law of sines to find side C. So we could find the rest of our information there. All right, questions there? All right, let's look at another one. B is 78 degrees, side C is 12, and side B is 5. We want to find angle C. So let's draw a picture. Always draw a picture. And I'm going to say this is 78 degrees, this is 5, and this is 12. So I'm going to say B is less than C, 5 is less than 12. Let's calculate the height. There's my height. Height is 12 sine 78, which comes out to be 11.7. So B is less than the height. So this height is almost twice as long as this side. And this angle can't change. So what does that tell us? No triangle. And we're done. This side that's 5 is too short to connect down there because the height is almost 12, more than twice as long as that height, or that side.
We can't find C.
So if you tried in your calculator, you would say sine C over 12 equals sine 78 over 5. So C is the inverse sine of 12 sine 78 over 5. If you plug that in your calculator is going to say domain error. And that is because 12 sine 78 over 5 comes out to be 2.35. Does any angle have a sine of 2.35? No. So your calculator is telling you that angle doesn't exist. So that triangle doesn't exist. So domain error is your calculator trying to give you a message that there's something going on, something fishy going on with that triangle. And the idea of your calculator talking to you reminds me of the computer student that told his teacher that the computer ate his homework. And the computer teacher said, don't anthropomorphize computers, they don't like it. You have to think about that one a little bit. Yeah, you have to know what anthropomorphize means. Anthropomorphize means give human qualities to. Right, right, the computers don't like it, right. See, that's what makes it fun. All right. So not only do you get math jokes, but you get combination of English and computer jokes. Yeah, you get to learn. All right. Another example. A is 29 degrees. Side A is 6 and side B is 10. And we want to find angle B. So let's draw a nice little picture. Well, I forgot to mention at the beginning, we're also going to learn a new formula for the area of a triangle today. This is 6, this is 10, and our possible angle B is down over here somewhere, if it works. So we're going to calculate our height. There's drawing the height. So from the information we have, we know that A is less than B. 6 is less than 10. So we need to compare A to the height. So our height is 10 sine 29, which comes out to be 4.85. So A is greater than the height. Just barely. So this is almost 5, and this is 6. So that tells us we get 2 triangles. So we have 2 possible angle B's. One of our triangles looks like this. 6 is barely larger than the height, so it looks something like that. So there is the one triangle. Looks kind of like that. A, B, that's 6, that's 10. And the other triangle is going to look like this. Yes?
If A is greater than B, do we even need to figure out the relationship with the height?
No, if A is greater than B, then you can only get one triangle. It's just, I just try to emphasize calculating the height is a good thing. All right, so from this first triangle, we would just set up the law of sines. I'm going to call this B1 and B2, 2 possible angle B's. So just like before, I'd say the sine of B1 over 10 equals, this is 29, equals sine of 29 over 6. So B1 is the inverse sine of 10 sine 29 over 6. And when you plug that into your calculator, you get about 53.9 degrees. So this angle is 53.9 degrees. No, I don't like that. There we go. Let me move that over. There we go. And then the other possible angle B, B2 is 180 minus 53.9, and that comes out to be 126.1 degrees. So this angle would be 126.1 degrees. And then we could find angle C and find side C, find the other possible angle C, and find the other possible side C. Hmm?
Why is it 180 minus 52.9?
So if I go back here to this drawing, this angle, this first possible angle B is supplementary to this other possible angle B. Because when I draw it out like this, they'll make a linear pair. Okay? All right. Questions? Okay, let's talk about our new area formula. So this area formula is related to the law of sines. So that's why we're talking about it now. So here's our triangle that we've been talking about for the last couple of days. What's the area? What's the area formula we know for a triangle? Area equals 1/2 base times height. Well, let's draw in the height like we've been doing the last couple of lessons. So there's my height. And we know that in this case, the height is C sine A. And what's the base? The base is B. So the area equals 1/2, and I'm going to write this as BC sine A. So to find the area of a triangle, we just need to know two sides and the angle between them, and we can use this formula. I could draw my height from another vertex, and I would get another formula, 1/2 AB sine C, or using the third vertex, 1/2 AC sine B. So we have a new area formula for the area of a triangle. We'll learn another one that's related to the law of cosines, and then we'll learn another one that has to do with vectors. So, for example, if you had a triangle where B is 143, A is 7, and C is 18, and we want to find the area. This formula is a lot like the law of sines, very easy to use. The area is 1/2 7 times 18 times the sine of 143. And we plug that into our calculator, and we get that that's about 37.9 square units. Yeah.
As far as rounding goes, does it just kind of like vary between the problems?
Yeah, the problem will tell you round to the 10th or whatever. If it doesn't tell you, if you round to the 10th, you'll be fine.
Okay.
All right, so now we know two area formulas for the area of a triangle. Questions? Okay. Yeah, 1:30. I'm not sure he does, Laura.